G is dash dash dot, so we should see 2 long and 1 short. Hey guys, today we will continue in our series where we go through the courses in FPGA Academy, and we will continue with Lab 5, timers and real-time clocks. Last time we finished part 1, 2 and 3, and today we'll look at part 4, and we will try to implement Morse code in VHDL. If you haven't seen the previous parts, part 1, 2 and 3, you can watch it on my YouTube channel, white brackets, and it's here part 14, real-time clocks, and you can watch the previous parts, and we will continue with part 4 today. We will try to implement a Morse code, so we will have these 8 letters, A, B, C, and all the way to H, and we will try to represent these in the Morse code and show the representation on the LEDs of the DE10 standard board. We will have switches 2 to 0 as input and also key 1 to 0 as inputs. So switches 2 to 0, they will select which of the letters we will show on the LEDRs. So for example, if all of them are 0, then we will select A. If it's 0, 0, 1, we will select B, and so on. And then key 1, when we press key 1, it will start displaying the Morse code of the letter, and key 0 will work as a asynchronous reset. The dots will be shown for 0.5 second pulses, and the dashes will be shown for 1.5 second. And also the pause between the dot and the dash will be also 0.5 second. And here you can see a schematic diagram of what we will try to do today. We will have our push buttons and switches as inputs. Here we will select which of the letters we want to display, and the letter size and the letter symbols, the Morse code symbols, will be saved in these 2 registers. The first one will save the size. So let's say A has size 2. And the symbols, it will be a shift register, and we can look at it here. So it will be a shift register, and we will save. So for example, here long will be 1.5 seconds, short will be 0.5 seconds, and we will save it like this. So we will take the last bit from the shift register. In this case, it's long. Long will be indicated by 1, short will be indicated by 0, and we will take the last byte, and it will shift to the right. So the next one will be in the last one, and we will put 0 in the first one. So this is how the shift register will look like, but we will get to that later. And then we will have some logic here that will display the Morse code and also a 2-bit counter. And this 2-bit counter will decide whether we are counting 0.5 or 1.5 seconds. And here I have some steps that we will follow. So we will try to implement these 4 steps. So first we will blink LED 0.5 seconds on and off. So it will just blink 0.5 seconds on, 0.5 seconds off, and switch between these 2 states. Then we will try to implement that it will blink for 1.5 seconds on and 0.5 seconds off. Then we will try to display A. So A is dot and dash. So we will try to display dot and dash when key 1 is pressed. And finally, we will select which letter we want to display based on the switches 2 to 0. So that's what we will try to implement. So let's look at step 1, and let's just try to blink LED 0.5 seconds on and off. I have my quarters project here, part 4, and also our VHDL files from the previous parts. So part 1, 2, and 3, and some other parts or some other entities that we have created. What I will do is, so we want to display for 0.5 seconds the LED. So let's look at this diagram again. Here we will have some clock. This clock will be 50 megahertz clock. That means it will count, or it will do 50 million cycles per second, but we want 0.5, or we want every cycle to last 0.5 second. So we will create a counter that will count to 25 million, which is half of the second. And this counter will count 0.5 seconds. It will work as enable for another counter. And this counter will either count to 0.5. That means it will count to 1, because this will work as enable. Or it will count to 1.5 second. So that will count to 3. So we will have our one counter here, then another counter here. This counter, that will be the 2-bit counter here. That's this counter here. And then we will have our LED. So first, let's create these two counters. I will import counter modulo, but we actually can import from the previous parts. So let's look at part 2, I think. Here we can import this counter. So here we have our, we'll import this counter, and also let's close these and import this one. And is this, and then we need, of course, these two signals. We just need this one and this one. And we don't even actually need this signal, so we can get rid of it. This signal was Q, so that was the vector of the counter, but we don't need it. We just need rollover. This signal is 1 in the clock cycle when the counter gets resetted. So if it counts all the way to some number and then it gets resetted, this signal will be 1 for the cycle where it will be resetted. So we have our signal here. This will indicate that the counter has reached the number, and then it will reset. It will count to 25 million. So that's correct here. 25 million means it will count. This signal will be 1 every half a second. So it's 26 bits, 25 million. If you don't know what, how did we come up to with these numbers, watch the previous episodes, because that's where we have made these, where we have made this counter, and it will have as input clock 50 megahertz. Switch 0 will work as enable. We will have one more signal. This signal will be called counter 50 enable. It will be std logic, and the default value will be 1. And this variable will work as enable. Then we have key 0 as reset, that's correct. And then we have our output. We need one more counter, and this counter, so let's create one more. And this counter will count to 0.5, which means it will be a 2-bit counter, and it will count to 1. That means it will just reset basically it will just start counting, and the next cycle it will just reset. Because this counter rollover will work as enable for this counter, and we need the rollover for, we will call this counter LED. It will be the counter for the LED, rollover LED. And I think that's all we need to do. So it will count 0.5 seconds. If I set this to 3, it will count 1.5 seconds. So you can change it like this. I will create some constant here. Constant. And this constant will be long symbol, it will be natural, and long symbol will mean it's, or it will be a integer, so 3, and short will mean it's 1. Short. So for short, the clock cycle will be just, for the counter will be just 1, and for the long symbol it will be 3 cycles of the counter. So here I can put this as short cycle. Not sure if I'm allowed to put it in the generic, but let's see. I'll put it like this. And so otherwise I think we have everything here, and I will create a process here as well. And this process will change with arrow LED, begin and process. And if rising edge of arrow LED, then, and if, and I will create a signal here called LED on. It will be STD logic, and it will be 0, like this. And LED on, oops, what have I done? LED on. Let's part 4, yes. Let's save this. Oh, so this is laptop level entity, so I don't forget. But let's let's change this to not LED on the rising edge of the rollover from the LED counter. So if this counter finishes the cycle, it will switch the LED on to a different state. So if it's turned off, it will turn on, and so on. And here at the end, I will say LEDR 0. So the LEDR that has the index 0, and it will have the value of LED on. So this will be on or off based on this signal. And I think this could work. So let's try to compile this. So we have our counter that counts 0.5 seconds. This counter works as enable for the next counter that will count either short symbol or long symbol. And this will then change the state of the LED. So this should be the first step. And let's test it out. Compilation is done, so let's try to program the board. Let's start. And you can see that the light changes every half a second. So half a second it's on, half a second it's off. And you can see, so we have finished part or step 1. So step 1 is done, and let's look at step 2. Blink LED 1.5 second on and 0.5 seconds off. So how do we do this? We will have to create a counter. So let's look at this entity, the counter, and this counter has count that counts 0 to some number. It counts to k. So if it's equal to k, it will reset. And we want this k to be variable. We want it to change based on what we need. So I will create a new counter. So I will copy the code from this counter, and I will create a new file, VHDL file. This will be called variable k, counter modulo variable k. I will save it here. Counter modulo variable k. And this, so we have generic here that indicates how many bits the counter has, and then k, and that's the number that it counts to. So in this case, this is a 5-bit counter that counts to 20. But we will no longer need the generic value here for the k, but I will have an input here that will be called max k. It will be in, and it will be a std logic vector, and it's gonna be the same size as here. So it's gonna be max k, and it will be std, and it will actually be natural. It will not be so natural. So we will have max k that's natural, and here we have the k that it counts to. So I will create a new signal, k. It will be also natural, and the default value will be max k. So this k will take the value of max k, and here, when we reset the counter, I will also set k to change to max k. So we will be able to, based on this input, we will be able to change the number that it counts to. So every cycle, every counter cycle, when it resets, it can count to different numbers. So it can count to 0.5, then it can count to 1.5 seconds, and so on. So this is a variable k counter. I will save it, and we will import this counter into our part4 entity as a component. And let's change this counter to this type. So we have to get rid of this, and I will create a new signal called counter LED max k, and it will be natural, and default value will be short symbol. And this will have 3 inputs, and then this. So here we will have counter LED max k as input, and it will indicate how long this should count for. So here I can change the length. So I will say if counter LED max k is equal to short symbol, then else, and if. So if it's short, then we will set it to long. And if it's long, then we will set it to short. Short symbol. So, or we can do it based on the LED. So if LED on is off, that means it's 0. We will display the short one. The short, and if it's on, it will be long symbol. So you can do it like this. And now when this is 0, and now it should do that. It will blink for 1.5 seconds on and 0.5 seconds off. Let's test it out. Let's try to compile. Compilation is done, so let's try to program the board. And you can see that it blinks for 1.5 seconds. So when it's on, it's longer than the off state. So the on is 1.5 seconds and off is 0.5 seconds. You can see there is a difference between the time. Longer and shorter. Okay, so seems that we have successfully finished part 2. So check this. And let's look at step 3, display A when key 1 is pressed. So now we will try to display A, and in order to do this, I have here a finite state machine that we'll try to implement. So we will start in this state that is finished, and when key 1 is pressed, we want to get to a new state that is called load letter. In this state, we load the letter. So in our case, it will be letter A. And then we will move to another state that is called letter loaded. In this state, we indicate that we have already loaded the letter. And from this state, we will go to load symbol. In this, we will load the first symbol of the letter. So if it's A start with dot. So we will load dot. And then we will go to show symbol, which will display the symbol. Then we will go to show space, that will display space, which is just LED off. Then we will go again to load symbol, we will load the next one, and then we will keep on in this cycle until the count is a variable that will, or signal that will increment every time we get through the cycle. So every time we show symbol, we will increment the counter. And if it's equal to size, we will go back to finish. So if we have shown the whole letter, we will start again, or we will go to finish, I mean. So let's try to implement this. And we will start by implementing, or we will start by defining the states. So T states is, and let's look at the syntax. So states in VHDL. So it's like this. So we will have to say type T states is, and here we have to define our states. So we will define finished, load letter, letter loaded. So finished, load letter, then letter loaded. Then we will do load symbol, show symbol, then show space, and finally, and that's all. So we need six states. And here we will create a signal called state, and it will be of type T states. So these will be our our 6 states, and this will indicate the current state. And we can get rid of this, and I will change this based on the clock. And we can get rid of this one. And I'll also include here if E0, that's our reset, is equal to 0, which is when it's pressed. Else if. So if it's reset, then we set counter enable to 0. And we set the LED on to 0. And yeah, that's all. And state, we will set the state to finished. Else if rising edge, and here I will have case state when finished, then we do something. And I will do this for all the states. So when others, state will be, we will just return to finished. And in finished, LED on. Finished will be basically same as here. So we can just set this LED on to 0, this one to, and here if key 1. So when we want to start, is equal to 0. So when this key 1 is pressed, and if. So if it's pressed, then we want to go to next state. So state will be load letter. Otherwise, we will just stay in this state. When we are in load letter, and for this, in order to load the letter, we will need the shift register. So we will need this shift register. So let's first create a shift register. I'll create a new VHDL entity, and I'll copy this. I'll call this shift register. And our shift register will have, we'll finish this, begin, end, and save it as shift register. So as you can see here, our shift register, that's this register here, has as input data, enable and load, and has one output. So we will have load and enable as inputs. They will be std logic. Then we will have data in as input, and data in will be std logic vector n-1 down to 0, and then we will have out, and it will be also n-1 down to 0, and we need to specify the n, so that will be generic, and here n will be natural, and it will be by default, let's say 8. So load will load a new letter into the shift register, and enable will get the next letter in the shift register. So it will shift the register. So load will just load the symbols into the register, and enable will shift the register and get the last one here as output. So let's do that now. I will create a new signal here called data, and this will be std logic vector n-1 down to 0, and this will hold the register data. And here, if load equals to 1, then else if rising edge of enable, then end if. So if load is 1, we want the data to be data in. Else if, here we will create our shift register. So if it's enabled, then we want data, and data out actually will not be vector, it will just be std logic. Data out will be std logic, so data out will get the last one from the shift register, so that means data n-1, and then we will shift the register. So data will be equal to data n-2 down to 0, -2, and 0. So we will shift it, we will get rid of this value here, and we will replace, in the first, we will replace it with 0. So if you look at it, we will replace this one with 0, so this 0 will come here, and all of these will shift, and this one will get out as output. And I think that's all for the shift register. So data, this seems correct. So shift register, let's copy the entity, let's save it, and let's go to part 4, and I will include it here. So we have counter modulo variable k, and shift register. And let's create one entity here. Shift, so this will be called, let's look, letter symbols shift register. So we will call it letter symbols. It will be shift register generic map. So the n in our case is the highest number or highest count, that how many symbols are here. So I think 4 is the highest. Yeah, there's the maximum number of symbols is 4. So our shift register needs to be 4. It needs to hold 4 bits. So n will be 4, and then port map. And here we need load enable. So I will create signals, letter symbols enable std logic, and let's set it to 0. Then I will need one more for load, and then we have data in, that will be our switches, and data out, so that will be letter symbol. So letter symbol will be std logic as well. We don't need to set it. So first is load. So I'll put load. Then enable. And then I will put here data in. So we want to put a, and a is dot and dash. So dot will be represented by 0 and dash by 1, and then we have 2 zeros. So dot, dash, and then we don't care about the 2 other values because they will not be displayed. And then we have our out, and that will be letter symbol. So that's our shift register, and then we need one more signal. It will be letter symbol size. It will be natural, and in this case it's gonna be equal to 2 because a letter has two symbols. And then I will create a count, and count will be 0. This will count how many we have already displayed. So we will start with 0, then we will go to 1, and 2 we will finish because we have shown all the letters, all the symbols. So we want here in load letter, we want to load the letter. So I will set, if we want to load, we want to set this variable to 1, and then go to the next state. State will be letter loaded. Then in letter loaded, we will change this back to 0 again. So we have loaded the letter into the shift register, and we will go to the next state. And the next state is load symbol. In load symbol, we need to enable this. So we load the symbol into the variable. Letter symbols enable. So that will give us the next in the shift register. And then we can go to show symbol. And in the show symbol, we will set the counter LED max K which is how long we want the LED to be on and off. So I will say if, and here we will use our symbol. And if this symbol is equal to 1, then else and if. So if it's equal to 1, that's our output from the shift register here. That indicates whether it's long or short, whether it's a dash or dot. So if this is 1, and if this is 1, then we want counter LED max K, which is natural. We want it to be long symbol, and else we want it to be short symbol. Then if the output of the counter, if the counter has reached the... So what we will do here is we will get to this, or we will get to this state, and we will wait for the counter to finish. And when it's finished, we will set it to 0. The LED will be turned off, and we will move to the next state here. And here we will keep waiting until the 0.5 seconds for the space is over, and then we set it to 1, and we will go back here. So in this, we will wait for the other one to finish. So here we are waiting for it to finish. So when this is finished, this is rollover let. That's a rollover from this counter. So if this is finished, we want LED on to be turned on. And we want to go to a state show space. In show space, we want set this to short. We will set it to short, and we will do the same here. We will also wait for it to, and then we will turn it off. So let's try to go through this again. So we are in this finished state. That's where we start. And we reset the counter to 0. So it's not counting in this finished state. It's not counting. And we need to also set, once we load the symbol here, we start counting. So here you will start counting. No, not here, here. So we stop counting and we turn off the LED. Then when we press key 1, we will go to next state and we will load letter. So we will load letter by setting this to 1, and we will go to letter loaded. We will set it to 0 again, and we will go to load symbol. We will load the first symbol, and here I will set this to 0. I will set it to 0. I will set the counter to 1. I will choose which one I want to display. So if it's longer or short, long or short symbol. And then I will keep waiting until the show space is finished. And when it's finished, I will display 1. I will change the LED state to 1. And then I will go to show space. In show space, I will change it to short. And I will keep on waiting until it's finished. And then when it's finished, I will turn off the LED and go to show space, and that's not correct. I want to go to load symbol. So let's check all the states. So here we want to go to show symbol. In show symbol, we want to go to show space, and in show space, we want to go to load symbol. Also here, I want to increment the letter symbol count. So it will be equal to letter symbol count plus 1. And so we have displayed this letter, so we increment. And here, if I'll put it here, or let's put it here, if letter symbol count is equal to letter symbol size, then else, and if. If it's equal to letter symbol size, then we want to finish. So here we will go to state finished. Otherwise, we will continue loading another symbol. Here, semicolon. Let's try to compile. And of course, I forgot here to create a process. So this process will change on enable, begin, end process. I'll indent this. So here I have to change this to case state is this. And here I need to also add end case. So here, end case. And I have also forgot to reset here the counter. So letter symbol count here will be set to 0. So this is the counter, and when we finish, we want to reset it to 0. So let's try to compile it now. Compilation is done. Let's try to run this on the board. And let's look at the board. So you can see that nothing is showing, nothing is happening here. So when I press key 1, we can see one short and one long. Let's try again. One short and one long. Also, while it's happening, when I press key 0, it immediately turns off. So I can turn it off. And this is A. So A is one short, one long. So we have finished this part as well. And the only part that is left is selecting which letter we want to show based on the switches. So for that, I will create a new entity, VHDL. I will import this. Let's close these. And this will be called, I will call this, let's see, select letter. It will have switches as inputs. I have them here. Switches. So switches will be inputs, and it will have as output a 4-bit number. So letter will be out. It will be std logic vector, and it will be 3 down to 0. And begin end. Save it as select letter. And this will be just simple mapping. So I will create a case here. Or I will create, I need to look at the syntax. So when called select when. So we want to use this with select, and here we will select our inputs, and switches will be just 3, so we need just 2 down to 0. So with switches, select letter, and we need one more output, and that will be called, that will be letter size. It will be, so what I'm doing now is I'm doing this logic here, and I'm trying to get the letter size and the letter symbols. So these two registers. So I'll have these two outputs. So letter size will be natural, and it's gonna be out like this. So we'll create two of these. And this one will be letter size, switches, letter, switches, letter size. And I will quickly fill it in with the values. So I've finished. And so first we select the letter here, and then here we select the size. You can, for example, see that this letter and this letter, they are just all zeros, that means all dots, but the difference is in their length. So this one is 1 and this one is 4. So if you look at it, E is 1 dot and H is 4 dots. So the difference is in length. Let's look at G. G is dash dash dot and it's 3. So the size is 3. And here we see it's dash dash dot, and then we don't care about the last one. So that's for select letter. And I'll include this as a component here. Like this. And let's create one instance of this here. Select letter instance. Port map. And it will have switches 2 down to 0, so 2 down to 0 as inputs, and it will output the, let's create a new here, and it will be called letter, and this will be std logic vector 3 down to 0. And it will select the letter, and this letter will be input to our shift register here. So we select based on the switches, the letter, and this letter will get loaded once this value is set to 1. So in our load letter, we set this to 1. This is set to 1. We load this letter that we have selected here, and then we display it. So that's all for this part. And one more detail. The letter symbol size doesn't change here. It stays as 2. So once we load the letter here, we also need to, because our select has 2 outputs, and the second output is letter symbol size. This is not letter symbol size, it will be just letter size. So let's change it here. This will be letter count. Matches. Here. This will be just letter count and letter size. And this letter size will also be set here. So I'll create a signal that will be called next letter size. Let's set it here. We can call this next letter as well. So next letter, and the select letter has 2 outputs, letter size and letter. And we need to change the letter size to next letter size to next letter size. And we will do it here. We load the symbol, and when we are loading, we will also change letter size to next letter size. Okay, let's try to compile now. And compilation is done. So let's look at the board. Nothing is happening here, and let's try to show A, for example. So A is one short and one long. But before we actually look at the board, let's look at some of the values here. So for example, we will try to display H and G. So G is dash dash dot and H is dot 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 dot. So 4 dots and G is dash dash dot. So let's look at the board. And I will set the switches. I will set them to all ones, which means we will now look at H. So when I press it, we should see 4 dots. And that's what we have seen. Let's try to see G. And G is dash dash dot. So we should see 2 long and 1 short. And that's what we see. Let's see. C is, we set it to 2. Now we set it to 3. And C is dash dot dash dot. So let's see. I think we have shown D. So this is C. So this is C dash dot dash and dot. So I hope you can see it. We can also reset and it stops. And that's all for this project. So we have finished part 4. That was a fun little exercise. And next time we will look at adders, subtractors and multipliers. And we are slowly approaching the simple processor. And that's really interesting because we will be able to program our own processor. So if you are excited about that as I am, don't forget to subscribe so you don't miss the next videos. And I will see you in the next one. Bye.